George, did you have a question?
What?
Do you have a question?
No.
Okay, cool. That was where you were there. Okay. I noticed number 3 might be a tad confusing just notation-wise. Let me just make sure it's clear what's going on in there. Might be a good rewrite, number 3. Not sure about 4? Okay. I would encourage you to do a rewrite.
Yeah, I did.
Okay. Did you do 2 rewrites? Like 2 different things need to be changed around a little bit? Let's say basically we don't want to have any fractions if we can avoid it. I would rewrite so that you don't have fractions, my friend. Next time we're going to look a little further, like what if you do have an integrand that's a fraction? But for now, if it's not an ln, if it's not going to work out nicely like that, we're going to do everything we can to avoid a fraction. So if you see 1 over x, I would rewrite that thing to be x to the negative 1. I wouldn't even hesitate. I would be doing some kind of algebra to get it to where it's easier to handle. That won't always work. In this case, it will. So it seems like 1 and 2 going pretty good. Some conversation about 3. Definitely a lot of conversation about 4. Seems how maybe it's going. So let's look at number 1 real quick. Meg, how'd this one go for you?
I did.
What'd you do? Like, what was your first thought when you read that?
Well, I saw like Tim really messed up the chain rule. So,
He did.
By a factor of 3.
Yep. So you fixed that.
So I times the integral by 3 inside of the took 1/3 outside of it.
Okay. Okay.
Plus C.
Does the plus c go up here with the exponent, or does it go down here on the base level? Yeah, it goes down the base level. Yep. All right, Meg, I think has a nice answer for us there. What if you were like Meg, but you were less confident, because she seemed like she was fairly confident in her answer? How could you check this to try to confirm that it was actually the right answer? The derivative, and it should end up being your integrand at the beginning, and if it's not, there's a mistake somewhere, either in your check or in your original work. So what do y'all think? Any questions about number 1? All right, Justin, what did you do with number 2?
For that one, I think the derivative was off by a factor of, I believe, -5 halves. Or I'm not sure like how you guys do it, but I put a negative.
I don't know what you mean by you guys, but
Like with the Timmy thing.
it's okay.
Yeah.
For sure.
Weird people.
Or
Weird
negative-
people?
Yeah, I put, yeah. So like, I put -5/2 on the outside. And then on the inside I put -10 x to balance that out.
Well, so hold on. You kind of lost me at 10. You said didn't you say you multiplied the inside by 10 or something?
I put instead of, what's that? Trying to figure out what when I did, so for you, I said it was u is -x squared.
By the way, I would way rather you explain it how you did it,
Okay,
not how you think I want you to do it.
okay.
Why don't you, if you wanted to do use, let's do use,
Okay,
by
so
all
then
means.
For the du, I said that was negative.
What'd you make your u?
U was -x squared.
Okay,
And then du was -2x dx.
okay.
So basically I saw that it was a 5 that's inside. So I divided, I moved the 5 to the outside and then divided by -2.
Oh, there we go. Okay. So I was waiting for Justin to say that.
Yeah.
We want to get the 5, which is a constant multiple. Let's get that out instantly, right? Let's not fool around with that. So I like that move. So I'll write that up here. So the 5 gets to come out, and then we
And I
get.
multiplied it by -2 on the inside of the integrand.
Okay.
Yeah.
And then you divided the outside by -2.
Yeah.
Okay. This is making a lot of
Yeah.
sense. This is making a lot of
I was
sense.
trying to like explain myself in this thing.
It's okay.
Yeah.
Hey, like being able to explain yourself
Yeah.
probably means you can write it.
Yeah.
And so it's good to kind of hash that out and make it make sense in your own mind while you're trying to say it. Okay, so Justin has definitely like manipulated all this and got things to the form they need to be. So then as you finished, what'd you get?
I'm not sure if this is right, but -5/2 is going to be to the -x squared plus c.
Be more confident in yourself.
Okay.
Thanks for encouraging, Nick. You're right. You're absolutely right.
Said you're wrong.
You're absolutely not close at all.
Great confidence.
I think it's well done. So like I would say like based on the way you explain that, I feel like you're almost doing a hybrid U substitution Timmy thing. I'm okay with that.
Okay.
You're using the U and the DU thing to get yourself organized, and then the way you said it, it sounded like you realized, oh, it's just a -2 that's missing for my substitution, so you just dropped it in, divided by the -2 on the outside, and then it made sense to you.
Yeah.
It's totally okay. Please don't ever feel like you need to respond to me in a certain way.
Okay.
Just tell me how you did it, and we'll go from there.
Cool.
Could be that your way is awesome, and I think it was. It was real good, for sure. Do you guys have follow-ups? Any questions on what you have just seen and heard? Okay, so then we get to number 3. Like I said, I think a little rewrite was helpful here, just to clarify, like, what are we doing the sign of? Because if it's the sign of all that other junk, it's a very, very different question than as it should be written up there, like I clarified in black. Aiden, what are you thinking? What was going on when you saw this one?
I decided to make cosine x equal to u, and then du equals sine x dx. And then it's pretty convenient because it's just the antiderivative of.
Wait a minute, are you telling me that Timmy didn't mess up? Whoa, what do you guys think about that?
I think
Julia?
It's negative sign.
Oh, Timmy did mess up a little bit?
Dude, Timmy sucks. He has
It was. He was super close.
Super
So Aiden, the truth is derivative of cosine is negative sine.
That's awkward.
So Timmy came real close. So Aiden, with that as an adjustment, do you think you can navigate it, or do you want me to give you a little space?
Yeah, I think I can.
Okay, so what would come next if we made that small adjustment?
Well, you can just pull the negative out as soon as you plug it in again. Negative antiderivative of sine x. Wait, no. Negative antiderivative of either the u du.
What do you guys think about that step?
That's good stuff.
Looks pretty good, I think.
Great stuff.
Looks pretty good. And then how would you finish this one off?
Well, then it's just negative e to the u plus c, which is negative negative e to the cosine x plus c.
I like it. I think it makes a lot of sense.
Snaps.
Okay, how we doing?
Very great.
Thumbs up? Was that a thumbs up?
That was true.
Thumbs up? Oh my goodness.
I didn't know how to do 4.
I don't know how to do 4.
Okay, let's talk about 4.
Wait, is that e to the 1 over?
Yeah, that is.
E to the 1 over x.
I got you, Mr. Anderson.
All right, so let me get to the right screen here. So here is number 4.
I
A
got
little
you.
bit zoomed in. Okay, so Jack, what'd you do?
So I brought that x squared up, so it's just x to the negative 2 times e to the x to the negative 1. And then Timmy messed up the chain rule by a factor of negative 1.
This is going to seem like a minor detail, but I feel like you lost some stuff.
dx. With integral.
Okay, I'm just going to write whatever you say,
Okay.
whether it's good or bad.
And then Timmy
Before you go too far with Timmy and his mess ups, what do you guys think about that rewrite? Does that make sense to you? I mean, Jack's a nice guy and all, but why would we do that? Why would you do that? Like, what was your instincts telling you?
Well, I don't like fractions. And if there's an exponent on the bottom and a variable, I'm like, I can take that up. And if it's just a constant, then it doesn't matter. I can just take it out.
True, just get it out of there.
So,
Yeah, sure.
rational, I'm always.
Let's go back to the first thing he said. When I see a fraction, I would rather it not be a fraction. So if I can,
I'll take it up.
turn it into something else, like by moving it up. All right, I think that makes sense. What do y'all think?
I love that.
Okay, so then Jack, keep going. What'd you do? You said Timmy something.
Timmy did mess up the chain rule by a factor of negative 1.
Okay, so if we just did this,
And you're going to put a negative 1 on the outside. Negative 1 over 1, which is just negative 1 on the outside. And then negative 1, so then negative x to the negative 2 will just go back up in, and so will the dx. Those guys will return to whence they came. And then it'll be just negative e to the x to the negative 1 plus c.
he's right. I feel like there's more for us to talk about. He's right.
I get it.
Thanks.
Once the x,
So if I
so
took
whenever
the-
x became like x to the negative 1 and we flipped up x squared, then I was like, oh, I see it.
Maybe if you saw the u, like maybe if you saw the substitution side. So if we came over here and we said,
-1 minus 1 was -2.
So a little.
Well, I brought x up and I said it was -x.
so check this out. Sit up, please. Hey. If you're not maybe totally seeing it, I mean, I think Jack's explanation was good, but if you're not totally seeing it, check this out. If we started off with this rewrite, I don't think there's any way that we can get around that. If you were going to make this a substitution, what would you make your u?
X to the
X to the -1.
Yeah. So then what's your du?
negative x to the negative 2. Yeah.
And that's kind of the light bulb moment where you think, oh my gosh, there it is. There's x to the negative 2. It's just off by a negative, right?
Oh, shit. My goodness.
Because at first, you got to admit, at first at glance, even after you do the rewrite, these two things don't seem to be that connected. You're like, well, they both have x's, but beyond that, I don't know if I see this. But when you do the du, maybe you do see it. That was a lot of do-dos and dus and stuff, right? Then maybe you do see it, and maybe the picture becomes a little more clear, and you can do the Timmy messed up the chain rule, or you can do the full substitution process. That's fine too. So anyways, I don't want to go too fast. I feel like things came together a little bit there.
Easy money.
Yeah, that was perfect.
Does light work.
Wow.
Okay.
That
That was
astounding.
I enjoyed that.
crisp.
Crisp. Okay. So then the next thing we're going to look at is how to handle definite integrals. And so again, like I'm going to always try to shy away from telling you there is only one way to do any of these. Certainly there are steps and principles and concepts that are in play here. But I want to be flexible, and I want you to be flexible too with how you approach these. And so I would say that all three of these, 5, 6, and 7, are all nice examples of where various procedures, various thought processes could all be valid as long as you're getting there to a valid, correct answer and all of your steps make sense. I think we're good. I like to think of this as like getting home. I can get home lots of different ways. I can get home by going on Highlands Ranch Parkway. I could always also drive up by Mountain Vista. Frankly, I could drive to Castle Rock and then take Santa Fe up to my house. There's lots of different ways I could get home. And if I get home, and as long as I didn't like go through any red lights or go 100 miles an hour, break any other applicable laws, right? As long as I don't do that, well then my way is okay. There might be a faster way, right? We could always find a faster way. As long as your way makes sense and you get to a good answer, I don't think anybody really can complain. That makes sense?
I love that.
So be flexible. Try to make it make sense instead of just I need to follow steps, I need to follow a procedure. That's okay, but it's better to be flexible. So anyway, so try these. I don't know, I intended for these to go from easy to difficult. We could certainly debate about that. So do your best working through these, and I'll check some answers here in a few minutes.
Nice.
Darn.
Nice, dude. It was definitely the socks.
It was.
Let's work with the stripes.
Thank you.
Okay. You're all welcome to share answers and ask questions. I'm just walking around. Hopefully seeing you make progress, but if you get stuck, let me know. Hope you all had a good weekend. This weekend was my son's reward for being potty trained.
Hey.
Was number 1 and number 2 in the toilet now.
Yeah.
So his reward was we went to a day out with Thomas the Train in Golden, at the Golden Railroad, or the Colorado Railroad Museum. Pretty fun. Good times. Yeah. There's some cool stuff up there. You guys know what a train turntable is? It's how they can like make a train just like turn directions.
Oh, yeah.
So it's like literally a turntable, like a record player,
Oh, yeah.
or a CD or
I
something.
had one of those
Yeah, we have one of those in our little training set at home.
There's a turntable for the play,
Yeah,
for the play that they're doing.
yeah.
They have a big old turntable.
It's just like that, except this one we found out weighs 40 tons.
I like the
Yeah,
more
it's like-
intense version of it.
Good to know. The locomotive, it can actually handle a locomotive up to like 150 tons. Locomotive 150 tons.
Negative e to the negative 1 plus e to the
Modern locomotives are closer to 200 ton, or
I see it.
no, wait. Modern locomotives, I think, are up to like 50 or 60 tons or something like that. I'm probably missing some of the details of it, just like huge numbers. And the cool thing is even with a big like 30, 40 ton locomotive on this turntable, there's no motor on the turntable at all. People can move it. They just have like a long lever arm. He said it takes about 4 people to move one of the big locomotives, but you just push and you move it. Get it turning.
Some nice physics.
And then get out of the way, right? Because if that thing hits you, it's not stopping. Even if it's only going like 1 mile an hour, it will just plow you over. Question of momentum, right? MV is very high, even though V is low. I don't know. If you haven't been to the Colorado Railroad Museum, recommend it. It's interesting.
Trains are
Oh,
scary.
that's so cute.
They're
And they
intimidating.
were like thinking what they did in like the 1800s with no computers, no calculators, nothing. It's so impressive. Just incredibly impressive.
They're just giant.
Yeah.
Like the ones that are trained from Kansas and Nebraska.
Yeah. Think how powerful all those locomotives have to be to pull those things. I
Train car is like 12 tons.
was going to say, yeah, 15 tons probably at least. Maybe more, depending on what's loaded on them.
And they're like 5 meters.
Yeah, it's genuinely impressive. Just like the sheer manufacturing and how do you make this and then how do you make it precise enough that it works? I mean, it's incredible. It really is. All right, let's take a look at the first two at least. Maybe we get to the third one. So, as you can tell, these are just like the other ones, except you've got limits of integration. It's a definite integral. So what's your first step here for 5 is to find the antiderivative. What do you guys think the antiderivative of e to the negative x is? There you go. Negative e to the negative x, or negative 1 e to the negative x, evaluated from 0 to 1. So at this point it becomes a correct order of plugging in and subtracting. So we always plug in the physically higher number first, and we subtract the physically lower number, something along those lines. So for those that like to simplify, this would be negative 1 over e plus what?
1.
Plus C.
What do you think? Any questions? Nice. Not too bad. All right, number 6 then. Number 6 is clearly composite. It's also a product. So what you'd ask yourself here is, essentially, did Timmy mess it up, right? Is the derivative of the inside the other factor? Did he mess it up?
No, sir.
He did not. The substitution works out perfectly. Timmy did not mess it up. So then, Logan, what would you say that the antiderivative part is?
It would be sine e to the x.
That's right.
Evaluated from 0 to negative 1.
Negative 1 to 0?
1 to 0, sorry.
There we go.
Same, yeah, sure.
So what'd you get for a final? Final expression.
I got sine of e to the 0 or sine of 1 minus sine of e to the negative 1.
So, you said which is 1.
Yeah.
There we go. Yeah. What do you think?
That's nice.
Okay. And then he explained, of course, that this is really sine of 1. So couldn't we use the unit circle at least to figure out sine of 1?
We've been debating on this.
We want to say that 1 is a unit circle angle,
But it's not.
but it's not.
You could do 0. Oh, 'cause
Sine of something is 1, right? Like sine of pi over 2?
yeah.
But sine of 1, I bring it up only because I've seen people say, oh, sine of 1, I know what that is. And then they throw something out there. It's like, well, it's some crazy decimal.
Yes, but actually, no.
It's between negative 1 and 1. You just want to be careful that you are actually really taking care with that unit circle stuff.
It's about root 3 or 2. It's pretty close.
Okay. Okay. I'll think about that. Number 7. All right. Hey, what jumped out to you about number 7? What showed up maybe unexpectedly? A fraction. And is this one of those ones where, you know how Jack said earlier, I don't really like fractions. If I can avoid them, I will. Is this one of those fractions we could just flip up?
All right, I think I know.
What if you did? What if you said integral from 0 to 1, you flip the denominator up to the top? Wouldn't it have to look like this? And there, listen.
I'm still okay with it.
There is so much temptation to do some ugly stuff, like some stuff where, we'd have to call the math FBI. Like if we did this, I don't know.
You know what's crazy is that
This is very, very.
You just distributed it an exponent.
I did. That's very bad, right? We can't do that.
You can't be out here like that.
Hold on.
No, in fact, I'm gonna erase the evidence. I'm gonna bleach that right on out of there.
Bleach the hard.
In case somebody happened to walk by and look in the classroom, I don't want them to see that. So try as you might to avoid a fraction here.
You can totally avoid the fraction.
How?
It's erasure. It's a natural law.
Well, yeah, if you do the antiderivative, but you can't avoid the fact that it is a fraction. You can't write the fraction out of it like you did with yours. That was smart.
But you just did that.
But, so if I did that, check this out. I shouldn't have erased that. Here we go. So if I do that, you could really fall into a trap here because you'd say, oh, look, Timmy didn't mess it up, right? Because the derivative of the inside is the other factor, right? The derivative of 1 plus e to the x is e to the x. And so maybe you would say, well, this just goes back inside, is right here. And so you would happily write 1 plus e to the x to the negative 1 plus 1 divided by negative 1 plus 1. And that's where you would say, oh, boy, I'm dividing by 0. That's a problem, right? So if you ever find yourself dividing by 0, go back. It's probably going to end up being natural log of something. Does that make sense? So that would be your hint that we can't get away from this being a fraction, like on some of the other ones. And get used to that. There will be plenty of others where we cannot get away from this being a fraction. So since it is a fraction, if the derivative of the denominator is the numerator, isn't that where we get the ln? The derivative of the denominator is exactly, or maybe just off by a Timmy factor. Here, he didn't mess up at all. So I'd say that the antiderivative is natural log of 1 plus e to the x.
The absolute value of.
You know what? I actually don't have to write the absolute value here. Normally we do. Why don't I have to write the absolute value around the 1 plus e to the x?
E to the x is always positive.
And plus 1 is even more positive. If it was 1 minus e to the x, got to write the absolute values because there's going to be some negative parts there. But here we don't have to. And you know what? If you did, it doesn't matter. It's fine. Okay, so then did you guys get natural log of 1 plus e minus natural log of 2?
Yep.
1 plus 1? 1 plus e to the 0?
Nice.
Okay. And then if you wanted to be super fancy, you could condense this down into an even more simple form. You know what it could be? Got it. Yep. You could write this as a fraction. Because the log bases are the same, you could condense the subtraction with division.
If we left it in the first way, would you take off points on the
Nope,
test?
not at all. Not at all. In fact, if you left it like this, I'd give that full credit as well. Great. That's right. You know, it's not as fancy or as nice as this form or this other form, but it's right. I mean, I hope to God that you know that e to the 0 is 1. I hope that I'm going to assume you're just being efficient. You're like, well, I don't need to take the extra minute to do this. Instead of like, oh my gosh, I don't know what e to the 0 is. I hope that's not the case. If it is, let's keep talking. Let's get you to a better place. But I get it. Get it. Okay. So then our final topic of the day is right here. It basically is, what if the base isn't e? That's basically the question we're trying to answer here. What if it's some exponential, but the base isn't e? So there's an intro video for these rules, and then as you can see, there's just a handful of opportunities for us to practice these. So this is, to some degree or another, intended to be a do you remember sort of a thing. So do you remember what the derivative of 2 to the x is?
No. I
Ouch.
just remember I hated this unit. It was really hard.
Say again?
I just remember like this unit was really hard for me
Okay.
last year.
I think, can I make a suggestion?
Yeah.
So I really honestly think that if you like those rules we just had,
Did you memorize?
I really think that's the best way. We can go through all the change of base formulas and all this stuff, but in the end, it's going to be most efficient for, like if I were you, I'm a flashcard guy. I would flashcard myself like for 5 minutes a day for the next week, and by the time the test rolled around, I'd be fine. If I didn't do that every day for 5 minutes,
Because don't you know the formulas? It makes it super easy.
it's a lot easier for sure. Yeah.
I remember doing that for AB, and I think I still have it.
So use them.
Hopefully I do.
Yeah. You could even I don't know. I don't know if I'd recommend doing it while you're driving, but if you're riding in the back of a car with someone, you could just flashcard back and forth with them, or you're in line for lunch, right? You know how we all stand in line forever? If you're on a date, yes, you could.
Really boring if it's not going well.
Homecoming date. It's a hint that it's not going well because like, hey, I got a calc test coming up. Will you flashcard with these with me?
Oh, this is so
How romantic, how special. Yeah. Well, let's do this then. Does anybody know? Are we like totally in the dark on this?
I honestly have no idea.
Start watching the intro videos.
I should.
You should. What is it? Somebody said it.
One of 2 times 2x.
Got it.
Queen.
Hey, what it do?
True.
What it do, who?
You want to know how I remember this? I remember that it works, or it needs to be able to still work with E. Like if the base was e, wouldn't you get ln of e times e to the x? And what's ln of e? So it'd be 1e to the x. We already know the derivative of e to the x is e to the x.
Wait,
So it would still work with e.
Is that 2 to the x?
Yep,
Oh, 2 to the x.
2 to the x.
So it's ln of a times a to the x.
That's it. I'll write it over here. Here's the general rule. The derivative of a to the x, Logan already said it correctly, is ln of a times a to the x, a being whatever the base on the exponential happens to be.
So I'm assuming it'd be ln of a times a to the u times u prime.
Yep, and that goes nicely with number 2, right? So what do you guys think number 2 would be?
3
ln of 2 times
2. Ooh, that's my bad luck.
2, not 2 to the x, 2 to the 3x. So that would be,
So embarrassing.
Wait, can you write out the rule for that one too?
can you look up, can you do what?
Wait, no, I'll just, wait, never mind. I'll just get it from the intro
I just did
video.
a nice log rule. That was nice.
Well, this is the same rule, right? So it's d dx of a to the u. So this would be ln of a times a to the u
I didn't.
times du dx, or u prime. The difference between 1 and 2 is that 2 is an explicit chain rule.
Has a U.
It's got a u instead of just an x. Yep. All right, number 3. Anybody remember this one by any chance?
1 over x ln of 4.
Nice, Julia. Well, she actually did her preparation by watching the intro, or she remembers really well, or something. There we go. So this is straight out of a change of base formula. Y'all want to see, I think, isn't this in, did I put this in the intro video? So here's how you actually get this. Let's say it's the AP test, or it's the...
Isn't that like what we'd have to use if we didn't have the button on our calculator?
Yes. So here we go. Here's how you could actually rewrite this. You could rewrite this as ln of x over ln of 4. That's how you change a base. Is you like, I want the base to be e, so you just make it ln of the input over ln of the base. I just remember the base goes in the base, right? The base goes to the bottom. And then this is really just y equals 1 over ln of 4 times natural log of x. And 1 over ln of 4, albeit complicated, is just a constant multiple. And so the derivative of ln of x is 1 over x. So y prime would equal 1 over ln of 4 times 1 over x, also known as 1 over x ln of 4. So you could just change the base over if you forgot the rule, and you'd get there almost as fast. So then what if it was a little more complicated, like number 4? Hopefully if number 3 is sort of clicking a little bit for you, thanks to Julia, then maybe number 4. Yes, number 4, very similar. Any guesses?
I got you. It's negative sine x over cosine x ln of 10.
Pretty good. What if you wanted to be ultra fancy and rewrite this?
Ooh, I got you. Negative 10.
Yeah, there we go.
1 over ln of 10.
Negative tangent of x over ln of 10.
Yeah, I tried. Yeah. That was a really good effort.
You don't have to go there. I'm just picking your brains about trig.
Way to take it there.
Seeing if you can remember.
I did. Yeah.
Okay, so the last one.
Hey, it's okay. So did I. Except
Well, before I erase, are you guys okay with 1, 2, 3, 4? To see how this is you need to watch the intro video, you need to get these solid, you need to flashcard them.
well, my teacher didn't.
Hey, listen, the reason why we're approaching it from this perspective, and I'm happy we can develop as many of these as you want, if you want to come in and do something like that. You know, honestly, on one of my tests, or like an AP test or something, you look at the whole test, it's not like there's going to be 9 of these questions on there. There might be 1, maybe 2. Okay, so we're not going to make this like the main thing, like maximums and minimums and related rates and all. Those are bigger concepts where we need to spend a little more time. But I will say, sure, I know you figured this out. Isn't every point valuable?
Oh, yeah.
And if you know these sorts of formulas, it's like 2 seconds later, you're done. It's easy, and you're like, well, that was a really easy point, which is good because the next one might be a lot more difficult.
Especially on
The
multiple
capture.
choice when it's the same.
They're worth the same. That's right. All right. So then the last one here is number 5. Are we all going to like lean on Julia on this one? Do you know this one, Julia?
Yeah,
I
1
got
over,
this.
no, yes, 1 over ln of 3 times 3 to the x plus.
Oh my goodness gracious.
She's right. She's right.
That was this one?
Can I help you?
The antiderivative.
That's why I was so confused.
Yeah. You know, another way to look at this is a Timmy messed it up thing. So if you're doing an antiderivative, aren't we essentially undoing like someone's version of a chain rule, like their prior effort at a chain rule? So if I look at this, 3 to the x dx, and I ask myself, is that really like an exact derivative of anything? The answer is like not really, because if somebody did do the derivative of 3 to the x, wouldn't there have to be another factor in there? What's the derivative of 3 to the x? There we go. It should be this, right? This would represent a perfect chain rule derivative of that. So we need to fix the fact that that's not there, and then we adjust for our fix by this. This does not go anywhere.
Wait, why is it ln of 3?
That's not what the derivative of like.
Go back to number 1, right? The derivative of 2 to the x was ln of 2 times 2 to the x. So for us to be able to anti-differentiate this, it needs to actually be the derivative of something. And without that ln of 3, it's not really the derivative of 3 to the x. With that in there, it is. And so then that allows that ln of 3 and the dx just to go back where they came from. We end up with this, and we get the plus c. Of course, it's the same thing. It's just a different mental approach.
Oh, plus c.
Don't forget the plus c. Yes, ma'am.
Would we ever have it with like the antiderivative of 3 to like the 2x?
Right, yeah, so I don't think so. Like,
Okay.
I've never seen one like that ever. We would just have to, if we did, we would just have an extra factor of 2 hanging out there.
Okay.
So, anyhow. Okay, tomorrow, or not tomorrow, Wednesday, we finish chapter 5. So, have a good rest of your day. If you think about it, print off your notes for the next unit
By Wednesday?
by Thursday.
Thursday? Oh,
I just finished this. I think it's chapter.
You will, that means
So
you're
it's, I'll
well
be here
done.
for the second half of class.